If math has been driving you crazy, or if you're finally admitting you're lazy, and your test grades have been dropping, it's time to get your arrows popping.
How's everybody doing? This is Mr. Witt with Fort Bend Tutoring, and today we have part 2 of our college algebra final exam review. Yes, we do. Let's go ahead and get some things lined up here. Get some things lined up. All right, is it lined up yet? Is it lined up yet? Kind of not. There we go. I think. There we go. Kinda getting lined up there. All right. So yeah, this is Mr. Witt. We have college algebra part 2. Michelle Lomas is in the house already. She says she's ready. That's great. That is fantastic. Why is this not looking all nice and cute for me right over here? What kind of thing is this going on over here? That's weird. Weird. Let me check this out here. There we go. That's better. I guess it's going to be the type of template that I have this set on for some reason. That's weird. Oh, okay, gotcha. I gotcha. This is the problem. Better. Now we're in session. Okay, so we got the screen looking the way it is, the way it needs to be. I got my orange juice ready, guys. I'm pumped up. It's part 2, final exam review for college algebra. Let me get my words together. And the screen is focused the way it needs to be now. So I'm feeling better about that. And let's just go ahead and get started with problem number 22. We're picking up from the last problem that we had last time, which was problem number 21. That's right. Charmaine is in the house. Good morning to you, Charmaine. There you go. People chiming in, people getting in the chat. That's right. And we're looking at a piecewise function, guys. And it asks us to find the value. And they're saying that the function of x, which equals to 3x, all right, given that x would be less than or equal to negative 1, or x minus 5, where x would be greater than negative 1, they want us to find out what f of negative 7 is. So the first thing you need to pay attention in a problem like this, that you're trying to evaluate the piecewise function, is the conditions. Yeah, you need to pay attention to the conditions. The conditions state that you're going to use this portion of the function when x is less than or equal to negative 1, whereas you would use the second part of the function when x is greater than negative 1. And our value that we're trying to solve for in this problem is the y value when the x value is negative 7. So that means that f of negative 7 would use this first part of the function here, the 3x. So that means you'll plug in negative 7 for this x and end up with a result of negative 21. Amen. Let's go ahead and move the chat out the way. It's in the way you couldn't see that. So yes, so the 3 times the negative 7 gave us our negative 21. And we will red box it. That's right, red boxing it on a Saturday with the college algebra part 2. Amen. What you think about that, Charmaine? What you think about that, Michelle? That was problem number 22. We just picking up where we left off with the last final exam review part 1 for college algebra. That's all we're doing here. That is all we're doing. Fabiola is in the house. What's going on? Yes, and Fabiola says that she is ready to also have fun. There you go. Also ready to have fun is Fabiola. Amen. Okay, well, you know what? Let's see here. It looks like we have a problem here that's not present. We're going to have to write that down. We're going to have to write this out here. So we have used Descartes' rule of signs to determine the possible number of zeros, whether they be positive or negative. Let's go ahead and write this out. I have to write down the problem here. Okay, we have negative, let's see, negative x to the 5th power plus x cubed plus 2x. Yeah. And then we'll have minus 7. Yeah. We'll do that. We'll do that. Yeah, that's what we'll do. So Michelle said that was too easy. That's it. That was all that was to that problem. That's right, Michelle. That's all we had for that problem. All right, well, hopefully we're going to end up with a decent problem here. This exponent on that second term is 3. I had to make it up on the fly because wherever my problem went to, I don't know. It was there earlier, and then it just dipped out on me. But that's okay. We're not going to let that stop this party. So I made up a problem. Let's see if it works out well. So when you're using Descartes' rule, in order to find the positive zeros, in order to find the potential number of positive zeros in the polynomial, in the equation, okay, you would need to check out, what's going on, Sebastian? You would need to check out the differences of the sign changes, all right? You need to count the number of sign changes is what I meant to say. Count the number of sign changes in your expression here. So you're going to start out as far as the positive zeros are concerned, noticing that we have one sign change from negative to positive, and then you have another sign change here from positive to negative. So as far as your potential positive zeros are concerned, and what we'll do is we'll create a P and I chart. And this P in I chart here is going to represent all of the potential positive zeros, all the potential negative zeros, and all of our potential imaginary complex zeros that we may have. What's going on, Sarwin? Good to see you. Finn is in the house. That's right. So what we'll do is we'll recognize that we have 2 potential positive zeros out of this expression. And let's say it's a function here. You know, let's go ahead and make that a function. Let's go ahead and hook this up with our f of x. There we go. Better. Now it's better. Okay. Had to recreate that from scratch, guys. All right. So the thing about the Descartes rule is that you're going to be counting down by twos as you find your sign changes. So when you initially start this out and count the sign changes in the problem, notice that we started out from a negative to a positive, and then it stayed positive, and then eventually it became negative again at the end. That made for 2 sign changes throughout that function. We're going to start out with our highest number of sign changes and then count down by 2 until you get to either 0, or you'll just stop, because you're not going to have a negative number of positive zeros that you can have. So we can say that we can have 2 or 0 positive zeros. Yeah, that's the way it works out. So we counted 2 sign changes, okay, from negative to positive and then from positive to negative. That gave us our initial value of 2, but then you count down from there by 2 until you get to 0 or a negative number, and then you stop. Okay, so we said 2, counted down by 2 and got to 0, and that's going to be your positive zeros. Now, for your negative zeros, using the Descartes rule of signs, you'll be substituting all the x's with negative x. So we will replace that first term with negative x to the 5th power plus negative x cubed plus 2 times negative x, then minus 7. Okay, had to warp that a little bit there at the end. So what happens here is you'll have a negative and then negative x to the 5th power, because it's an odd exponent, will give you a negative result. So that negative times a negative will give you a positive x to the 5th power. Then you'll have that negative x raised to the 3rd power. Once again, because you have a negative base raised to an odd exponent, you'll also have a negative result. So that's negative x cubed there. All right. Negative x cubed. Let's bring that negative sign up. There we go. And then we'll have positive 2 times negative x. That gives you negative 2x. And then why am I writing my negative sign so low today? There we go. Let's bring it up. And then finally we have our negative 7. Yeah, that's what we have. So notice that once we have substituted all of our variables with the result of the value of negative x and then simplified it, we will then now count our number of sign changes again. So I'll have a positive to a negative, and then it stays negative, and then it stays negative. So we end up with only 1 sign change here. So therefore, I'll have 1 negative result, no matter what. So we have either 2 positive results or no positive zeros, but we will definitely have 1 negative zero no matter what. Okay, because remember I said that you're going to count down by 2's when you get that initial number of sign changes, but you can't have a negative result. So if I started out with just 1 for the negatives, I can't say 1 minus 2 is -1. So I'm not going to have a -1, -0. So that's not going to happen. So you just stop at the 1. Okay, but remember your highest exponent needs to be accounted for. So because you have the initial function with a degree of 5, that means that you'll end up with 5 solutions. Yeah, whether they're real or not, you'll have 5 solutions. But notice in this first scenario where I have 2 positive results and 1 negative result, well, that would leave us with 2 complex numbers remaining because it has to add to 5. So that means I have 2 real zeros, okay, 2 potential real zeros that are positive, and then I have 1 real zero that's negative, and then I would have 2 complex zeros in that case that add all to 5. Yeah. And then because of this second scenario where I would have 0 positive zeros, 1 negative zero, for this to add to give us 5, that would mean that we would end up with 4 complex zeros in that case. So if they're asking us for the number of positive zeros, we would say that the number of positive zeros, potential positive zeros that we would have, would be 2. All right, or 0. And then as far as the negative zeros, you would just have 1 no matter what. And then if they ask for any imaginary or complex zeros, you could have either 4 or 2. Okay, so that's where you're looking at your results for problem number 23 that I had to make up on the fly because I had a nice problem for you guys there, but it disappeared. Yep, had to make that one up on the fly. That's right, live streaming. You got to be ready for anything. Gotta be ready for anything. And that is problem number 23 using the Descartes rule. And for any of you guys that wanted to have a full-fledged PNI chart created, there you go. Just note that it has to add horizontally to the highest to the degree of your function. And that degree was degree 5. That is the Descartes rule of signs. Amen, amen. All right, moving on, guys, to problem number 24. Problem number 24. It says find the value of the expression. We have e to the 3 times the natural log of 4 as an exponent. Oh, that just looks nasty. Let's go ahead and see. Let's go ahead and write this out again. All right, so we can use some logarithmic properties here to simplify this, guys. So in using your logarithmic properties, we're going to state that that coefficient in that exponent, that number 3 there, it can be raised up as an exponent on that base of 4. So we can rewrite this as e to the natural log of 4 to the 3rd power. That's what we can do. And anytime you have a scenario like this, where you have the e value, okay, raised to a natural log, that e and that natural log will cancel out to leave you the exponent of 4 to the 3rd power. And of course, 4 to the 3rd power means 4 times 4 times 4. So the answer to this is 64. And this is the answer to problem number 24. So we're using our logarithmic properties to raise that coefficient up as an exponent using the power rule for logarithms. Okay. And then because there's an identity that states that if you have e raised to a natural log, that value itself becomes the result, becomes the answer. So the e, in other words, the e and the natural log will cancel out in that case. Amen, amen, guys. All right. So make sure that you guys are sharing this stream with all of your friends and your family. The people that you love, the people that you hate, the people you haven't talked to in a week or two. Okay. And then make sure you're liking the video and subscribing to Forbidden Tutoring, guys. All right. We have problem number 25 in the house. With problem 25, it says convert to exponential form. Convert to exponential form. So we already are given the equation in logarithmic form. We have log b of c equals to a. And we want to convert this into exponential form. So the way it works is you're going to take the base of the logarithm That becomes the main base in your exponential form. It'll be raised to your value on the right side of the equation. So it's going to be b to the a power. And this equals to that value of that logarithm that you were trying to take, which is in this case, c. That's it, guys. That's it. It's over. It's over. That is converting logarithmic form to exponential form. Done and done with a red box. That's right. Very good, Rahul. Very good. You have exactly the correct answer. It is b to the a equals c for converting problem number 25 into exponential form. Good job. Good job. All right. Elijah, I'm in 9th grade and just joined, and I have no clue what is going on. No problem, Elijah. Well, you can join in and you can find out from the beginning of a problem to the end of the problem how to work something out. But thank you for joining in, Elijah. Good stuff. All right, so we just had Elijah join the party. So here we're going to be moving on to problem number 26, Elijah, where we're dealing with a matrix. That's right. So in this problem, it says to find the determinant of the given matrix. Rahul says that I am awesome. Well, Rahul, all of you guys are awesome for joining me this Saturday morning. All right, I appreciate that, guys. I appreciate the love. Oh, yeah. All right. So when solving a problem like this, if you have a 2 by 2 matrix, as we do right here, what's going on, Jamila? We have 2 rows and 2 columns in this matrix. So when you have a 2 by 2, all right, and you're looking for the determinant of this matrix, we can follow the form that, let's say that this matrix is B, all right? Then the determinant of B, if it's in the form of A, B, C, D, then you would end up doing the following here. You would multiply A times D minus B times C to find out what the determinant of that matrix is. All right. So that means in this case that we'll have negative 6 times y minus negative 8 times x. So you'll end up with negative 6y plus 8x as a determinant of that value. Elijah says, is that an absolute value? Normally it would be, Elijah. That symbol normally is for the absolute value. However, when you're dealing with matrices, it means that you are finding the determinant of the matrix. In a normal situation, those vertical bars around that B would mean to find the absolute value. However, when you're dealing with matrices, it stands for finding the determinant of the matrix. Good question and good statement. All right, lovely Pookie is in the house talking about I'm in 8th. I just want to learn something new so that would help me in the future. Absolutely, lovely Pookie. All right, thank you for joining. Thank you for joining. And Rahul already had his answer correct. Good job, Rahul. You on the roll this morning. And we red boxed it. That's right. Well, that was problem number 26. And we're moving on to the next problem. All right. Moving on to the next problem. We have another problem with matrices. Problem number 27 says perform the indicated matrix operations. We are entering the matrix. Oh, yeah. That's what we're doing. So it's telling us that our first matrix, which is a 2 by 2 matrix in dimension, by the way, we have 2 rows and 2 columns, contains the values negative 3, negative 1, 0, and negative 4. Our second matrix is also a 2 by 2 matrix. All right. And that's important that you know the dimensions, guys, because you have to have the exact same dimensions when adding or subtracting matrices. They must have the exact dimensions of one another when you are adding and subtracting matrices. So because they have the exact same dimensions, then that means we can add the results together, add them together. We can also subtract them, okay, if asked. And then in our second matrix B, we have negative 4, negative 1, 4, and 0. Rahul has already presented us with his results. Let's go ahead and see if he's correct, guys. So we're going to start out with the scalars here. We have negative 2 multiplying on our matrix A. We also have positive 4 multiplying on our matrix B. When you have a scalar like this, when you have a number in front of your matrix that they have defined already, that means that every element within needs to be multiplied by that value. All right. So Elijah says, I do apologize. Something came up in real life. Hey, no problem, Elijah. I thank you for at least chiming in for the few minutes that you did. You take care. Enjoy. All right. So this is what we'll do, guys. We're going to go ahead and rewrite our matrices, the first matrix, by finding out what the result would be after I multiply everything by -2 in that first matrix. So I'm going to have this here arrow here. All right, Elijah says U2 piece. So we're going to end up with our first matrix looking like this. We'll have +6. We'll have +2. We'll have 0. And we'll also have +8. This is our result of our first matrix after we multiplied all the elements by -2. Good stuff. Then I'll be adding to that the result of me multiplying every element within the matrix B by 4. So that means that 4 times -4 gives me -16. 4 times -1 gives me -4. Then I'll have 4 times 4, which is +16, and then 4 times 0 is 0. It's at this point that all of our corresponding elements will be added together. All right. So what I'm showing thus far is my -2a as this first matrix now, because I had multiplied all the elements by -2. And then this is the 4b, the second matrix, because I multiplied all the initial elements in B by 4. And now I'm at a point to where I can add all of the corresponding elements together. That means I'll end up with 6 plus -16, which gives me -10. I'll have 2 plus -4, which is -2. I'll have 0 plus 16, which is 16, and 8 plus 0, which is 8. And we will end up red boxing this answer here and also checking Rahul's results to see if he was also correct. And he has -10, -2, 16, and 8. And Rahul is on fire, guys, because he got the answer correct again for problem number 27. That's right. We had to red box it, Dan. You better believe it. We had to red box it, sir. That's exactly what happened. All right. So now Dan says that the answer is never correct without a red box. And he's absolutely correct. You got to protect that answer. You got to protect it. All right. Good deal. Here we have problem number 28 with find the product of AB if possible. Okay, so we're asked to multiply these two matrices together. We have a 2 by 2 and another 2 by 2. That's right. The first dimension is 2 and the last dimension is 2 as well, because we had 2 rows and 2 columns. We also have 2 rows and 2 columns as well. The columns of the first matrix has to be the exact number as the rows of the second matrix in order for you to be able to multiply them together. All right. So since this number matches that number, since the columns of the first matrix matches the number of rows in the second matrix, we can multiply these together. That's that part of the problem. That's part of the directions that says if possible. Because if these numbers were different, it would not be possible to multiply them together. Okay, so that's why it was important to check out the dimensions of the matrices that you were given first to verify whether or not the product of them would be possible. And we did that already. Okay, so that's what we have. So now in order to set this up, we'll end up with a 2 by 2. Those are the remaining dimensions here. So the result is going to be the rows of the first matrix and the columns of the second matrix. So we'll end up with a 2 by 2. Okay, so I'm going to go ahead and make some room here. I'm going to draw a big matrix here so I can show my work. And the way it works is you're going to be moving across the first matrix and down the rows of down the columns of the second matrix to create each of the elements within your result here. And I'll show you exactly what I'm talking about. For starters, they're going to be respective elements that'll be multiplying, and then we'll combine them together. You'll have -2 times -2 plus 3 times -1. And that will become the result that goes in that first element, that 1, 1 location in the matrix. All right, meaning first row, first column. Then let's go ahead and make some room here. Okay, good. Here we go. All right. Then, guys, for our second element in the first row, you'll say that you have, negative 2 times 0, all right, plus 3 times 4. All right, let's fix that. Looks ugly. It looks ugly. Let me fix it. There we go. All right. So notice that I went across the first row and I came down the second column for this element right here. Then I'll be doing that same process for the second row in my result. So I'm going to be moving across the second row in the first column, in the first matrix rather, and then coming down that first column in the second matrix. So we'll be multiplying 3 times negative 2 plus 2 times negative 1. So let me go ahead and state that again because I know it was a little jumbled. I was moving across the second row in the first matrix and coming down the first column in the second matrix. So I multiplied 3 times negative 2, and then I'm going to add 2 times negative 1 in this process of multiplying these two matrices together. So next up for this final element here, we'll be multiplying across the second row in the first matrix and down the second column in the second matrix. So that means I'll be multiplying 3 times 0 plus 2 times 4. And then now to find out our final result, we're going to combine these values. We're going to go ahead and simplify it using our order of operations. So we know that negative 2 times negative 2 is 4, and then 4 plus the result of this product, which is negative 3, we'll have 4 minus 3, which is going to give us 1. Then over here, negative 2 times 0 is 0, and 3 times 4 is 12. Then for the second row, we'll have 3 times negative 2 is negative 6 and negative 2 combine to give us negative 8. And then finally, 3 times 0 is 0, and then 2 times 4 is 8. So we end up with 1, 12, negative 8, and 8. And this is our answer for the product of those two matrices. That was a 2 by 2 by 2 by 2. And once again, Rahul is on fire, guys, because he has the correct answer. Good job, Rahul. All right. Rahul's going to be checking all of my work today. Yes, he is. So we have in problem number 29, because we're keeping it moving, guys. I have so many problems to share with you guys in preparing you for your college algebra final exam. Remember that this is part 2 of a 2-part series for your college exam final exam review. And you can catch that first part of the college algebra final exam review on the YouTube channel Fort Bend Tutoring. So make sure you check that out as far as that is concerned. It'll be in a playlist called Final Exam Reviews. All right, if you didn't catch part 1 of this final exam review for college algebra. So in problem number 29, guys, we are asked to determine the equations of any horizontal and vertical asymptotes. All right, and I can never say that asymptote, so I'm sure I'm butchering the name. I can never say it right. So let me try it again. Vertical asymptotes. Oh, Lord. It's going to be messed up, guys, so just bear with me on the pronunciation of that. What's going on, Doreen? How's it going? Good for you to join in with us today. So let us look at the vertical asymptotes first, all right? And matter of fact, you know what? Let's go ahead and factor this first. Let's do that. Let's factor completely this rational expression. Let's do that before we do anything else. So in factoring this, we'll have the following. The numerator is a difference of squares, so you'll have x plus 3 times x minus 3. In the denominator, 2 factors of 15 that'll subtract to give us 2 are 5 and 3. So we'll need to factor that into x plus 5 times x minus 3. Okay? So, what's going on, John? How you doing? Or Jane? Is it Jane? It's Jane. How's it going, Jane? Good to see you, sir. All right. Rahul says, yeah, that would make x minus 3 cancels from the numerator and the denominator. That's correct. So, what we can do, first of all, Rahul, is state that we'll have a whole here, okay? Because if you cancel this out and you simplify your rational expression to x plus 3 divided by x plus 5, you'll end up recognizing that you'll end up with a hole in this problem. Okay, so there's going to be a hole, and we can go ahead and find out the point of this hole. This hole will be located at 3 as your value of x. If you set that x minus 3 equal to 0 and solve for x, you'll end up with x equals to 3. And then if we were to plug 3 into our simplified form here, we would end up with 6/8, which will be reduced, all right, to 3/4. So there's going to be a hole in your function at 3/4. So that's just a little icing on the cake, guys, because they're only asking us for the equations of any horizontal and vertical asymptotes. But we needed to verify whether or not we were going to have a hole, because you're not going to have a hole also be a vertical asymptote. They're not going to be doing both. Okay, so therefore, if I know that this denominator factor of x minus 3 is a hole, that's not going to count as one of my vertical asymptotes. So that's good of us to go ahead and identify that we had a hole at 3/4. Okay. So Doreen says, I'm struggling with complete solutions to two variable equations. The negative and positive is what's getting me. All right. I guess I would have to see an example of that, Doreen. All right. And maybe we'll end up looking at a problem like that as we move along through these problems today. Okay. So then, with our remaining simplified rational expression, to find the vertical asymptote, you'll set that denominator equal to 0 and solve for it. So that means if I have x plus 5 and set it equal to 0, the equation for the vertical asymptote is going to be, after subtracting 5 to both sides, guys, it's going to be x equals -5. And this is the vertical asymptote right here. And it has to contain the variable, the equal sign, and the number. All right. So all of that needs to be included. That's why they said determine the equations. So it's not just a value that you're looking for. -5 is not going to be the answer. It has to be the entire equation, x equals -5, that you need to submit as a solution. And now what we'll do is we'll look at the fact that we have a possibility for having a horizontal asymptote as well. All right. And like I said before, go ahead and bear with me, guys, on that pronunciation. I can never pronounce it correctly. I don't know why, but it's just a case that, yeah, it's going to be jacked up. All right, let's go ahead and get this expression written down correctly. It's supposed to be x plus 3 divided by x plus 5. There you go. I had it right. I thought I had it wrong, but I have it right. Okay, so here we go. So once again, for this rational expression that's simplified now, we already figured out where the hole will occur. We already figured out where our vertical, what the vertical asymptote equation is. So now for the horizontal asymptote, what we're going to do is recognize that the degree in the numerator is 1 because our x is to the first power. The degree in the denominator is the same. It's also x to the first power as far as the degree is concerned. So in a situation like this where you're trying to identify what the horizontal asymptote is, you take the terms with the highest degree and you simplify them if they have the exact same degree. And they do in this case. The degree in the numerator is 1. The degree in the denominator is 1. So we will ignore these remaining terms and simplify x over x to end up with 1 as the result. So as an equation, the horizontal asymptote is y equals 1 and done. That's it. That's the answer. So altogether, we are going to end up with a vertical asymptote of x equals -5, as well as a horizontal asymptote of y equals 1. And because we were showing off this morning, we even told the instructor, hey, we're going to end up with a hole at 3/3 by finding out that factor that canceled out, setting it equal to 0 to get your value of x, and then plugging in that value into your simplified rational expression to end up with the y value of your hole. Dan says, would you do any radical equations expressions live stream soon? Sure. Yeah, I can definitely do that. Dan. That's not a problem. I'll put it on the list, and we will do some of that rational equations and expressions with the live screen. Rahul says, oh, I was confused about the answer. Thanks for clearing that up. No problem, Rahul. No problem. Right. So by identifying the hole first, Rahul, you're able to eliminate that potential vertical asymptote from your answer. So the x minus 3 is not going to also be a hole and a vertical asymptote. It's going to be one or the other, not both. So because that x minus 3 canceled out, it's not going to be a part of the vertical asymptotes. So we only count that x equals -5 as a vertical asymptote. That x minus 3 that canceled becomes how you find out where the hole occurs in the graph. Oh, yeah. All right. And Dan says, woohoo! That's what Dan has to say. All right, so here we have problem number 30, guys. Keeping it moving. They ask us to condense the expression 1/3 times the quantity of the log base 4 of x plus log base 4 of 5 minus log base 4 of y to the logarithm of a single term. So they're asking us to combine this all into one. How about that? So let us begin. And we'll begin within that first set of brackets there, realizing that anytime you have addition of the exact same logarithm, you can use the product rule for logarithms. And that means that I'll end up with log base 4 of 5x. That's right. You'll multiply those values of those logarithms together when you have an addition sign, when you have a sum of logarithms. All right. And I'm just going to drop that second set of brackets. Those are not necessary. Okay. What we can also do is we can make the coefficient of our first term into an exponent. All right. So Rahul has already submitted his answer here. Let's see if he's right. We'll have log of the quantity, and this is log base 4 of 5x raised to the 1/3 power minus log base 4 of y. All right. So once again, I use the power rule by converting that coefficient of that first term into the exponent on that value that we're taking the log of. All right. Now, notice that we have the difference of logarithms. So this will be the quotient rule for logarithms that we'll use here. And anytime you have subtraction of the exact same logarithms, you can rewrite it as a ratio, okay, as a fraction. So I can say that I have log base 4 of the quantity 5x that's being raised to the 1/3 power divided by y. And now, let's go ahead and get that a little closer here. Let's get them a little bit more snug. There you go. There you go, guys. Now y'all a little closer. You can be friends. And so you may see the answer written this way, or they may write it in radical notation. So they could say that they have log base 4 of the cube root of 5x divided by y. All right. And most likely you would see it on a standardized test in this second way, but both are the correct answer. And so we were able to take that expanded form that they gave us initially, and we were able to condense it into one single logarithm, and that's what they're referring to. And if we want to be really, really cute with this, I guess we could go ahead and put parentheses around that to show that that entire quantity is going to be that we'll take the log of that. All right, so we're going to have it like that. There you go. There you go. That looks cute, right? That looks cute. Let's go ahead and red box this. So I'm going to put a red box around these results here. There we go. So out of these results here is the correct answer. Let's see what Rahul was talking about. He said that he had the log of 5x over 4. Over 4? To the base of 4 to the 1/3? Is that because you to the base of 4 to the 1/3? Oh, wow. You did it a different kind of way, Rahul. I would have to have some more time to verify your version of it. I'm thinking that you probably used the change of base formula in order to create that and then went from there. I like my version much better, Rahul. I'm not going to lie. Okay. So I'm thinking that you tried to use that you didn't try, but you may have used the change of base formula once you got down to the final result and then went from there. But I think my version is a little cleaner. All right. Oh, you're misinterpreting the y as a 4. Yeah. No problem. Yeah. That's definitely a y. It's definitely a y. All right. Dan says 2 red boxes are rare. That's right. It's not oftentimes, Dan, that you can end up with multiple results that are submissible as your answer in mathematics. But in this case, yeah, I do. Okay. So there you go. Let's keep it moving, guys. That was problem number 30. Now we have problem number 31. Okay. And this system is a nonlinear system. All right. So we have a nonlinear system for problem number 31, and they ask us to solve the system of equations for real values of x only. So that means that they don't want any complex results. They don't want any complex numbers, no imaginary answers for our results in problem number 31. All right. So we'll be keeping that in mind. So anytime we enter into a path that will lead us down a complex number, we're going to not do that at all. All right, let's see here. Doreen says on finding the slope and don't get how the negative and positive works. Oh, okay, got you, Doreen. You know what, Doreen? You know what? I'm going to go ahead. I think I might go ahead and solve your problem right now. Doreen has a question, y'all. Let's go ahead and hook up Doreen, since she was so nice today, asking me a question. And since it is related to college algebra's questions, let's go ahead and hook up Doreen. All right, and we're going to call this D1 for Doreen's problem. How often does this happen, guys? That during a final exam review that we have a problem done on the fly. So that's what happens when you join Mr. Witt and Fort Bend Tutoring for a live stream. You may end up with a custom problem done for you. All right. I'm writing down what Doreen has on the screen, guys. Okay. And Doreen says that the directions to this are to find the slope. Okay. Let's see what we got, guys. Rahul, you ready? Let's get this done. Danielle says, I failed 2 out of the 3 math exams. Now I need to perfect the third to pass. Well, Danielle, you are doing something to perfect it by chiming in on this review today. So hopefully you'll see some things and some concepts that'll help you out. All right, good stuff. So with problem D1 from Doreen, we are asked to find the slope. So we're going to be starting out with the slope formula, Doreen, and I think this may solve your issues. Start out with the formula. The formula is y2 minus y1 divided by x2 minus x1. Label your points. I'll label it as x1, y1, x2, y2. So I have all the values labeled in my points. Rahul already has his result already. He has -3 halves as his answer. Let's see if we can get it. And I also have the formula written down, Doreen. So I always, anytime I'm using a formula in mathematics, I want to write it down before I start plugging in values. So let's go ahead and plug it in as the formula says. The formula says to plug in y2, which is -7. Then put a minus sign, and then your value of y1. So that y1 value needs to be negative. So show it with parentheses, Doreen. Okay, so notice that I had -7, which the formula asks for. The minus sign is part of the formula. Then the value of y1 happens to be negative, so show it with parentheses. Then in the denominator, it asks for the x2 value, which is 5. Then a minus sign, then our value of x1. Our value of x1 is 1. Okay, so that's why we just go ahead and put it in together. Stephen says, are we doing a live stream tomorrow? Not tomorrow, Stephen, but we'll be back live on Thursday. We stream on Thursdays and Saturdays. All right, so thank you for asking, Stephen. If you click that bell notification next to the subscribe button, they'll give you a notification that we're live. All right, so do that, Stephen. Mario says, what app is that? It's called Penultimate by Evernote. Penultimate by Evernote is the name of the app, and it's only for the iPad. All right, so in the numerator, you'll have, and it may be for a tablet as well, an Android tablet, but I definitely know it's not for the iPhone. Okay, so it's only for the iPad as far as Apple is concerned. All right, so we have -7, then we'll have +1 divided by 5 minus 1, just taking my time with it. Then from there, we end up in the numerator with -6 divided by 4, and then we'll simplify this to -3 halves. Done and done. We have a red box on its way for Doreen. Done and done, guys. There you go. So that was a custom problem on the fly asked by Doreen, who now has an answer from Mr. Witt about her question. There you go. You can't get much better than that, Doreen. Huh? How's that? How'd you like that? Was that explanation good enough, Doreen? Talk to me now, lady. Let me know if that was okay. All right, good deal. Guys, please share the stream with people that you know and love, some people that you hate. All right, Doreen says thank you very much. You're welcome, Doreen. Thank you indeed for asking. All right, and also if you're able, guys, there's a $sign at the bottom of your super chat. And you can donate to Fort Bend Tutoring as that helps us with the free math tutorials like the one you're watching right now. Okay, so if you want to help out Fort Bend Tutoring in our endeavors of sharing our services with the world for free, go ahead and donate to the channel to help us do that. All right, there's a PayPal link in the description box that you can use, as well as if you're live in the chat with me right now, you can use that super chat option to donate at the bottom of your screen there. You'll see that there's a right down there. There's a $sign right down there in the super chat. You see that? You can use that to donate. Amen, amen. Let's go ahead and move on, guys. Let's catch back up to where we were in the problems that we're doing for you. We were dealing with a nonlinear system. All right. So with this nonlinear system, they want us to find out the real solutions, the real intersections of these two functions, guys. And when it works, when I'm working a problem like this, I always try to solve for one of the variables, and I always try to solve for the easiest one. Okay. The easiest variable to solve for. So when I'm looking at this, I know I have a circle in that second problem. That second equation is a circle. I know that the first one is a line. Okay. I'm not sure, Mario, if this app is available on Android, as I am an Apple fanboy. So I do not know if it's available. But it is called Penultimate by Evernote is the name of it. All right. So we got Dan, we got Raul with their answers. Okay. So let's see who is correct. I'm going to start, guys, by solving for y in the first equation. So I have 2x plus y equals 5. I'll be subtracting 2x to both sides of the equal sign. Y equals to negative 2x plus 5. And now that I have this, I'll be using this value to substitute into the second equation. That's right. Let me come on with my purple circle here, guys. So with my purple circle, Dan, I have negative 2x plus 5 that I'll be replacing the variable y, placing with that variable y in that second equation. So we'll rewrite this second equation as x squared plus the quantity negative 2x plus 5 squared, and this equals 10. From here, I'll be expanding that binomial, all right, that's being squared. So I can go ahead and distribute it all out, multiply it out, FOIL it out, get my arrows popping is what I mean to say, okay? So I'll end up with x squared, all right? Let's go ahead and get that chat out the way. We'll have x squared. This will be negative 2x times negative 2x. That gives me positive 4x squared. Let's give me positive 4x, guys. No, I was right. Positive 4x squared. Let me get my lot together. So negative 2x times negative 2x is 4x squared. Then we'll have negative 2x times 5. That gives me negative 10x. Then I have 5 times negative 2x, which is another negative 10x. And then 5 times 5 is 25. And this still equals to 10, guys. There you go. I had messed that up right there. That was supposed to be equal to 10. All right. Good stuff. All right, so you guys are figuring it out. Doreen says you're great for taking the time to show me that even though it's behind from where you are. No problem, Doreen. Just trying to do my best to help out those in need. So let's go ahead and simplify this, guys. We have 1x squared plus 4x squared gives me 5x squared. We have negative 10x and negative 10x. That's going to be negative 20x. We have a positive 25. And we're still setting this equal to 0. Let's go ahead and capture this because we definitely will be taking this to the next page here. Let's go ahead and copy that and paste it. All right, and let's continue. Let's continue with this problem here. From here, I'll be subtracting 10 to both sides. Dan, I don't know who's right or wrong just yet. We're going to figure it out together. So we have 5x squared. Unless you already plugged it back into the original problem to see if it worked, Dan. That's how you'll know whether or not your answer is correct or not. And notice that we have everything divisible by 5. So I'm going to divide the entire equation by 5 here, guys, because I would prefer to have a simplified equation. Once again, we're just on a journey here to solve for x initially. So we'll have x squared minus 4x plus 3 equals 0. So once factored, because this is factorable, we'll end up with x minus 3 times x minus 1. So for your values of x, after setting these both equal to 0, you'll add 3 to both sides here. And so x equals to 3. And you'll add 1 to both sides here. So you'll end up with x equals to 1. But recall, we said that y was equivalent to negative 2x. And was that plus 5, guys? Let me go ahead and check. Yeah, we did. We said that y was equivalent to negative 2x plus fast. Steven says, can you teach me some tips or techniques on doing factorizations faster? Yes. Go ahead and look at our playlist, Steven. That's called Factoring by Fort Tutoring. There you go. And I go over all of the techniques that I use to factor quadratic trinomials as well as other polynomials. So on the YouTube channel, Fort Tutoring, there is a playlist for factoring. Check that out. It's already in order. So you can start with the first one and work your way on down. And I show you all types of tips and tricks to factor all types of polynomials. All right, so that's where you can get that information, Steven. All right, so we have two values of x, guys, that may work in our original equation. But the first thing we're going to do is find out what their respective y values should be. So thus far, we have x equals to 3, maybe, and x equals to 1, maybe. So to find out their respective y values, if I plug in 3 for y in this equation here, we'll have negative 2 times 3 plus 5. This gives us negative 6 plus 5, which gives us a result of negative 1. So this first point would lead us to this first value of x would lead us to a point of intersection of 3, negative 1, potentially for our solution. Okay, then if we use our value of 1 for x and plug it into that same equation for y, we'll have y equals to negative 2 times 1 plus 5 to give us negative 2 plus 5, which equals to positive 3. So the other potential point would be 1, 3. Okay, so that means that we end up with 2 points of intersection, possibly. But of course, these values have to work in the original equation. So let's test it out to see if they work. Let's start out with the 3, negative 1. I think it was 3, negative 1. Yeah. Well, let's start out with 3, negative 1. Okay. And see if it works in both equations, because that's the only way that you can verify that the solution, other than using a graph, that's the only way that you can tell whether the solution works in our system. It has to work in both equations. So remember, we're going to try 3, negative 1 to see if that works. So this says 2 times 3 would be 6, and then 6 minus 1 gives us 5. So that works in the first equation. That's cool. In the second equation, we would say 3 squared is 9 and negative 1 squared is 1. So 9 plus 1 does equal to 10. So that means that 3, negative 1 is a valid solution. Next, guys, I think our second point that we found was 1, 3. It was 1, 3. So let's see if 1, 3 works in our original system. We would have 2 times 1 plus 3, and 2 plus 3 does equal to 5. That works. Yeah. What's going on, Bronze Beauty? Do we have a GED math video? Not at this time, Bronze Beauty. But you could actually use the ASVAB playlist. Check out the playlist called ASVAB, ASVAB, and that will help you prepare for the GED. All right. Good stuff. Danielle says, what time do live streams start on Saturdays and Thursdays? On Saturdays, I start at 10 a.m. Central Standard Time. And on Thursdays, 3 p.m. Central Standard Time. Yeah. Poly King is in the house. Just finished his math final. No more school work, and it's pouring outside, so figured I'd hang out with you. Good stuff, Poly King. Congratulations on your final. I already know you aced it. I already know you did well. Thanks for hanging out. All right. Bronze Beauty says, thanks. I'll look at that. Good deal. All right. So let's go ahead and bring up the chat so you guys can see out there. All right. So we're verifying whether our second point of intersection is correct and it works in the original system. We are looking at the point 1, 3 in this nonlinear system. So if I plug in 2 times 1 to give me 2 plus the y value of 3, that does equal to 5. And now we need to verify if that works in the second equation. So we have 1 squared plus we have 1 squared, which is 1, plus 3 squared, which is 9, and 1 plus 9 does equal to 10. That means that both of these values are solutions to the system, guys. So, Raul and Dan, it looks like, all right, sorry, Danielle, sorry that your internet is lagging behind. Looks like the correct solutions here, all right, are going to be 1, 3, as well as 3, negative 1. Okay, so Raul and Dan, can y'all verify that for me? Because I believe I just verified it with the system. The system says that both of those points will work. All right, good stuff. Raul says, darn, I got it incorrect. No problem, Raul. That's why this stream is beneficial to you guys. All right, so that you can go ahead and correct any mistakes that you've been making so that when it comes time for your final exam, you'll get it right. Bronze Beauty says also, do you have a video for proper use of scientific calculators? There is a video called Nonlinear Systems, which is similar to what we just did right here, Bronze Beauty. And you can, in that video, I'm using a graphing scientific calculator in that, and I show you different techniques as far as using that particular scientific calculator. All right, so you can check that one out, Bronze Beauty. It is called Nonlinear Systems Part 1, I believe. Yeah. No problem, Raul. And no problem, Dan. I am here to help, guys. Let's move on to our next problem. How about that? Okay, we have problem number 32. Dan says, I'm in high school, just like practicing math. Dan, you were almost on point, man. You were so close to the correct answer. So you doing what you can now in high school is only going to make things better for you, Dan. Lorna is in the house. I need this bad. I'm having a hard time. That's why I'm here to help, Lorna. And don't forget to check out part 1 of this college algebra final exam review. Okay, it is on our main page. It's on our page, and it's also in the playlist called Final Exam Review. Stephen Chung says, good night, guys. At least for me, I'm going to watch this live stream tomorrow. By the way, I'm from Malaysia, and now it's about 12 a.m. That is awesome, Stephen. Glad we can meet one another across the globe through the internet, which is awesome. Because I'm in Houston, Texas, man. And you're way in Malaysia. That is wonderful. Thank you for joining us today. Libby's in the house. What's going on, Libby? Libby says, Mr. Witt, you're our hero. I'm doing my best, Libby, to be a hero to all that I can, and even to myself. All right, so thank you for your support. I appreciate all you guys, and you guys can help me a lot by sharing this stream with your friends and family, the people that you love, the people that you hate. And also by liking the video and also subscribing to Forbidden Tutoring. And in addition to that, if you're able to donate to the channel, as that helps us bring you more free content like what I'm doing right now. That's right, a final exam review. Good stuff. You can use the super chat icon at the bottom to donate, as well as there is a PayPal link in the description box. Here we have a exponential equation, guys. And we are going to solve this. And the first thing I'm going to do, we have 2e to the x equals to 10. The first thing I'm going to do is just simplify the equation. I'm going to just simplify the equation by dividing both sides by 2. So we'll end up with e to the x equals to 5. Once we have this, we will then use natural logarithms, if I can say it right, guys. We're going to use natural logarithms to assist us in solving this equation. So with that base e right here, if I use a natural log to both sides of the equal sign, in other words, take the natural log of both sides of the equal sign here, I'll be able to use the power rule for logarithms to bring that variable in front as a coefficient. So I'm now able to rewrite this as x times the natural log of e, which equals to the natural log of 5. All right. And anytime you have the natural log of e right next to one another, they cancel out to 1. So this is equivalent to x equals to the natural log of 5, just as Raul has. Raul, you got it right again, sir. There you go. Back on point. And here is our exact answer, the natural log of 5. Most classes, guys, won't expect for you to use a calculator or anything like that. They'll just accept the exact answer as a natural log of 5, unless you're in a rare class that allows you to use a calculator. All right. Most college algebra classes do not allow you to use a calculator for good reason. All right. Because they want you to show off how good that brain of yours is and get the answer yourself. All right. So we boxed it for problem number 32, guys. Good job, Raul. You're on fire today. Here we have problem number, and Raul is in India. Awesome. Good stuff. Tell all your peeps in India I said what it do, Raul. Okay. So we have problem number 33. And it says to find the determinant. Remember, we did a determinant earlier in today's final exam review. All right. Good stuff. And Raul says they do not allow the calculators for that course here. Dan is from Canada. That's right. Canada is in the house. Neighbors to my country, the United States of America. Good stuff, Dan. All right, so here, guys, we have another determinant problem. The reason why I wanted to do another determinant problem in this same section of the final exam review is because the previous problem contained variables. I wanted to make sure that you guys knew the exact numbers that you could end up with when finding the determinant of a 2x2 matrix, okay? So, just to refresh your memory, that anytime you have, and I'll go ahead and write this in orange here, that if you have a matrix of the form A, B, C, D, that the determinant of this is going to be the difference of AD minus BC. Okay, let me fix that C. There we go. That's a better C there. So that's going to be the formula that we use in order to generate the determinant of our matrix A. Okay, so Raul says that the result that he has is negative 47. And then Tony says, Noah, solve 3x minus 7 equals to 5. All right. So who's Noah? Is Noah in the chat? I didn't see Noah in the chat, Tony. So are you just asking to solve the equation 3x minus 7 equals to 5? I can hook you up with that. Let me finish this problem first, okay? So here we have the determinant for the variable A, for the matrix A rather, and it's going to be the result of multiplying negative 3 times 7 minus negative 2 times negative 8. Simplifying this, you'll end up with negative 21 minus 16. So the opposite of negative 2 is 2, and then 2 times negative 8 equals to negative 16. So Tony is telling his son in the middle of our live stream, guys, to solve an equation. Well, Tony, I will help you out with that parenting, okay? And I will do that problem so we can verify whether or not your son Noah gets the answer correct or not. All right, so that's what's up. So in doing this problem, finishing this up, we have like signs, so we're going to end up combining the negative 21 and the negative 16 together, and we end up with negative 37. Raul, negative 37. Okay, so this is what we have as an answer for the determinant for matrix A. Raul, go ahead and verify that I did that correctly. Did I do it right, Raul? Because I ended up with negative 37 compared to your negative 47. So did I make a mistake? Raul says, Tony, all right. So Tony is helping out. Tony is helping out Noah. All right, good stuff with his problem. And I'll go ahead and do that. But Raul, I need you to let me know if I got my answer right. But Raul is being a good patron and helping Tony out and Noah. All right, good stuff. So here I end up, guys, with negative 37. Danielle says Mr. Witt is the only math teacher that sounds like he generally loves mathematics. You are wrong, Danielle. Do you know what you're hearing in my voice? What you're really hearing in my voice is my love for helping people. I'm not that great of a mathematician at all. I like helping people. So if you're hearing joy in my voice, it's because I'm having an opportunity to help people right now. That's where it's from. It's not the mathematics. Mathematics is just a vessel that I'm using to help people. It could be in anything. Okay, so it could be English. It could be a different subject. It could be just picking up trash on the street. Who knows? But it's my joy of helping people that you're hearing in my voice, not the love of math. I love that math allows me to help other people, but it's not mathematics itself. because I'm a mediocre mathematician, guys, just to let you guys know the truth about the thing. What you're witnessing is my God-given talent for teaching. So if you think I know math well, that's not true. The truth is I'm a good teacher, a really, really, really good teacher, but I kind of suck at math. All right. So here we have negative 37, and then we have El Pollo. I'm in Cal 3 now, but just wanted to drop by to say thank you for helping me through algebra last spring. Your videos go great. Hey, it was my pleasure, El Pollo Loco. My pleasure. Good stuff. Good stuff. Libby says, oh, that's so sweet. Thanks, Libby. But it's the truth, though. It's the truth. So you guys want to see an awesome mathematician? You guys want to check out Patrick JMT out of Austin. He's awesome. He has a YouTube channel. Now, he's an awesome mathematician. Me, I'm just mediocre. All right? I'm just so-so. Yep. But as far as being a teacher, I'm an awesome teacher. That I do know. All right. So I think we're going to help out Tony real quick with that problem for his son. Let's go ahead and input a page. So we're going to go with Tony's problem for his son next, and then we'll get back to business. So this is going to be T1 for Tony and Noah, okay? And that equation is 3x minus 7 equals 5. Yep. Getting the problem right. Okay, Tony and Noah, this one's for you. So Lorna says, so, but good. So, but good. Okay, good deal. So in order to isolate your variable here, Noah, is what you want to do. You want to get that term with the variable by itself first. So notice that we have a minus 7, a negative 7 on the left side of the equal sign. Get the term 3x by itself first by using the additive inverse, aka the opposite of that value. So the opposite of negative 7 is positive 7. So right now we're using the addition property of equality right now. So what you do to one side of the equal sign, you can also do to the right side of the equal sign, okay? You must do that to keep it balanced, Noah. From here, we'll end up with 3x, and 3x would equal to 5 plus 7, which is 12. Next, we'll be using the division principle of equality by dividing both sides by 3 because you want to solve for a positive 1 of your variable. So 3 divided by 3 is positive 1, and you bring down your variable x, and 12 divided by 3 is 4. So Noah, we're going to put this answer of 4 in a red box. And there you go, Tony and Noah. There is your problem. So hopefully you got that answer right for your dad, Noah. All right, since he wanted you to check that one out. And then we're going to get back to this final exam review. So here we have to solve the quadratic equation, guys. All right, and I believe what I want to do in this problem is I want to use the quadratic formula in order to solve it. This equation is not factorable, so you can't use the zero factor property in order to use it. You'll have to use either the quadratic formula or completing the square. And I do have a completing the square problem for you guys that I'll be doing in just a few minutes after when we get to it. But for this particular problem, I believe I want to solve it using the quadratic formula. Once you have an equation in the form of ax squared plus bx plus c equals 0, we can use this form to use the quadratic formula in order to solve for it. So that means that using the quadratic formula, which is x equals to negative b plus or minus the square root of b squared minus 4ac all divided by 2a, we're going to use this formula to plug in those values of a, b, and c from the equation, and then we'll simplify it to get our answer for problem number 34 here. Let's go ahead and identify what these values are. I know that the coefficients are the values of a, b, and c. So therefore the a value is 1, the b value is 2, and the c value is 2. Raul already has his results inputted, guys, so you can go ahead and check his work as I work out this problem for problem number 34 here using the quadratic formula. So plugging in my values, I'll have negative 2 plus or minus the square root of 2 squared minus 4 times 1 times 2 divided by 2 times 1. So that's what I end up with after doing my substitution. Let's go ahead and remove that chat so you guys can see better. Sorry about that. So we'll end up with negative 2 plus or minus the square root of 4 minus 8 divided by 2. You'll then have negative 2 plus or minus the square root of negative 4 divided by 2. And I think we'll go ahead and take this to the next page, guys. Let's go ahead and copy this and move on to the next page. Looks like we need to create a page. There we go. Let's insert a page here so we can continue. All right, good. Here we go. Getting it together, guys. All right, so inside of the radical here, I have a negative value. So we will be using complex numbers at this point. So using the imaginary numbers, I'm going to rewrite this as -2 because notice that taking the square root of a negative is impossible, all right, with real numbers. So that's why we're going to be switching over to using complex numbers to solve this problem. So I'm going to rewrite it as 4 times I squared, knowing that the value of I squared is equivalent to -1. Okay, so when you're using imaginary numbers, recall that I squared equals -1. You'll be using that a lot, guys, all right, and you'll know it will come up in your final exam. So above all things, remember that I to the second power equals to -1. Okay, so I'm replacing the negative underneath the radical sign, underneath that square root sign, with I squared to rewrite -4 as 4I squared, and that's still all over 2. Now, taking the square root of 4I squared, you'll end up with 2I divided by 2 now. Okay, what's going on, Angry Hermit? Glad you could join us. So then we'll be simplifying this because you're responsible for writing your answer in A plus BI format. You have to write your answer in this form so that the real number comes before the imaginary number. All right, you have to write it in that form so that it'll be proper. You have to have your answer written in standard form of a complex number, which is A plus BI. So in simplifying this, you'll have -2 divided by 2, which gives me -1, plus or minus 2 divided by 2 is 1I. So this will be my solution here. If you're looking at it as a solution set, guys, you'll have x equals, and then of course a brace. Oh, that's a decent brace for me. I did a decent brace. I'm excited about my brace. Let me just revel in the just bask in the joy, the sunlight of the brace I just made, because I suck at drawing braces, and this brace is decent for me. Okay, I don't know about your braces, guys, and how you guys get down with your braces, but my braces normally suck, and I'm excited about this brace right now. I'm just gonna look at the brace for a while. That's all right. Yeah, Dan says just red box the brace. You know what? I'm gonna do exactly that, Dan. This brace itself, the brace itself gets a red box. There you go. Polar King says, "Yeah, you finally did a proper brace." You know what I'm talking about, guys? Do y'all guys not know how much I struggle with my braces? Man, that brace is on fire. Tony says, "No one wants to know what you're writing on and where you got it." I am writing on an Apple iPad Air, Tony. I got it from the Apple store. You can also get it at Best Buy and some other stores. And the app I'm using is Penultimate by Evernote. Raul says one of my solutions was wrong. Okay, we can't have that, Raul. Okay, we can't have that. Yeah. So yeah, I see your real number should be -1 regardless, right? So the answer here, guys, let me go ahead and finish writing my answer out here. It's going to be -1 minus I, comma, -1 plus I. Okay, and then we'll finish up. All right, that's gonna work for us today, guys. That's gonna work for us. So I'm gonna red box the answer that includes that red box for that brace. All right, I don't want to confuse people. So let me go ahead and get rid of that brace right there, that box right there. So yeah, let me fix this, guys. I'm having too much fun. Oh man, I tore up the brace. Hold on, guys. We can't tear up that brace now. There we go. Let me just let's just fix it like this. There we go. All right, good stuff. Better. We'll just do it like that. Red boxception. Oh man. Too funny. All right, so yeah, so you could write the answer like this. All right, depending on some of your solutions that you may find on your final exams, guys, they may use the plus or minus signs. But if you expand it, then it will look like this. Okay, just to keep things on the up and up. All right, FBT in the house. All right, there we go. Sorry about that. Didn't mean to blind you guys. All right, good deal. And that is how we do the red box in there. Look at Jamila chiming in with her yay. All right, so that's that problem. I'm very excited about that, guys. Had some decent braces in there. That was awesome. In problem number 35, we are asked to write the expression in a plus bi format. So notice, once again, we're dealing with imaginary numbers. That previous problem, we were solving a quadratic equation using the quadratic formula. And Polly King coming down with a $10. Y'all check a look at this. We got Polly King in the house, guys. Polly King is in the house again with the donation, guys. $10. Thank you so much, Polly King. Polly King says $10 for getting me through the math final and a perfect brace. Polly King, you're bringing me to tears over here, man. I appreciate the love, man. That is awesome. You guys go ahead and make sure you're sharing the stream with your people. Like the video. Make sure you subscribe to 4-Bit Tutor if you want to see more live streams like this. Go ahead and click that bell icon next to the subscribe button so that you'll be notified that when we're live streaming. All right, good stuff. Polly King, man, you are consistent. I can tell you that. If I could like duplicate you times 10, all right, we'd have something serious going on around here. But that is awesome. Good stuff getting through your math class, Polly King. I'm so proud of you, guy. So proud of you. And I really, really appreciate your generosity. That is really cool. $10 donation, guys. What you got with that? So with that. All right. Good stuff. Let's keep it moving, guys. We have this product of binomials. We're going to be multiplying everything out using the distributive property. And you better believe, guys, especially with Polly King's donation, I will be getting my arrows popping. Oh, yes, I will. Getting these arrows popping, guys. So we have 3 times 1 gives us 3. 3 times negative 2i is negative 6i. We have 4i times 1, which is a positive 4i. We have 4i times negative 2i, which gives us negative 8i squared. Just like that. That's right. Rahul says that Polly King is dude. He is the dude. He is that dude for sure. All right. Then we're going to be simplifying this, combining our like terms here. We'll have 3. Negative 6i plus 4i gives us negative 2i. Let's go ahead and hook that up. And we also will have a negative 8 times negative 1 here. So remember, guys, that I just said in that previous problem that I squared is equivalent to negative 1. Oh, yes, it is. Oh, yes, it is. And we'll be combining these signs here, multiplying that out. We'll have 3 minus 2i plus 8. But you must write your answer in standard form. In standard form for a complex number is a plus bi, guys. Standard form for a complex number is a plus bi. So that means you write the real number before the imaginary number. I see that Raul did it correctly this time. Good job, Raul. So we'll have 3 plus 8. That gives me 11 minus the 2i as our final result. We must have that real number of 11 before the imaginary number, negative 2i. And that's it. And we're going to red box this with Polly King giving us another donation to help us in our endeavors of helping people around the world for free. We can easily do that with your support. And Polly King is always at the head of the pack with the donations. Appreciate that, Polly King. You are awesome. Jamila put it down last time. That's right, Jamila. I appreciate your donation for last time. That was awesome as well. I appreciate you. So, guys, let's move on to our next problem. Once again, giving Polly King some love up in this piece. Way to go, Polly King. Thank you so much, guys. And congratulations on completing your class this semester. All right. And for that perfect brace that I made. You know what I'm saying? Got to give me a little credit for that perfect brace too, right? Don't want to take that away. We have problem number 36, guys. We're asked to solve the equation 2x squared, which equals negative 4x minus 5. In this problem, guys, I'm going to show you guys how to attack this problem using completing the square. Okay, so this time we're going to use completing the square to solve this problem. And when you're completing the square, you want to isolate the first 2 terms in your standard quadratic equation. And just to remind you what I'm referring to, the standard form of a quadratic equation is ax squared plus bx plus c equals 0. And I'm saying that what we want to do first is isolate the first two terms here. Okay, isolate those first two terms. So we'll do that by adding 4x to both sides of our equation here. And we'll use completing the square to assist us in this problem. So we'll be able to rewrite this as 2x squared plus 4x equals negative 5. Our next concern is that we want that first term to have a coefficient of 1. We want the first term to have a coefficient of 1. It does not. Currently, it has a coefficient of 2. We don't want that. So what we'll do is we'll simplify the entire equation by dividing everything by 2. So when we simplify this, we'll have x squared plus 2x blank equals to negative 5 halves blank. All right. Good and good. Next, we'll be taking half of the middle term's coefficient. So half of 2 is 1, and then we'll square that value. That's the value that we'll be putting inside of the blanks here. So 1 squared is 1, and I'll be adding that to both sides of my equal sign here. The left side will be easily factored, guys, by simply taking your variable and whatever half of the middle term's coefficient was. So this could be rewritten as x plus 1 squared on the left side. All right, Polar King says, so glad I learned completing the square through you. Quite a few people left the final right getting scolded for not following directions. Wow, that is crazy. So Polar King, one of the questions on the final exam told you specifically to use completing the square, that you had to do it that way, and that if you didn't do it that way, you would, they used the quadratic formula on that, and they got scolded because of that. That is a trip, Polar King. Let's go ahead and show Polar King some love here with the chat that he is talking to me right now. So yeah, guys, so make sure that you're paying attention to the directions on your final exams. They may specifically tell you which method you must use in order to solve the equation. Okay, so in this problem, we are just freely using completing the square, but they may tell you to use a specific method. So you may not have a choice, as we did in problem number 36. We chose completing the square this time, but the directions may have forced us into a specific method, as Polar King is telling us. Oh yeah. So Polar King is warning you guys for your final exams that it's very important to use the method if indicated. So if they tell you to use a specific method, whether it's the zero factor property, or they could say solve by factoring, they could say solve using the quadratic formula, they can say solve using completing the square, or they could even say solve using the square root property. Okay, so there's going to be 4 different methods that they can present to you to solve a quadratic equation. You need to make sure that you're reading your directions. Thank you, Polar King, for that warning. So that you guys can make sure you're getting your full credit for your answers on your final exams. Thank you, Polar King, for sharing that with the group here. Okay, that was great information. Absolutely. So thank you so much. So even after the class, Polar King, you're helping in all kind of ways today. You're just showing off. I know you're just showing off over there. All right, let's check out our right side of the equal sign, guys. Because we have negative 5 halves plus 1, I'm going to rewrite that 1 as 2 halves so that I can combine it. So we'll end up with negative 3 halves in this scenario here. Okay, so we have x plus 1 squared. All right. That's right, Polar King. You'll show off today. Dan says, Mr. Witt, I have to work on my computer project. Hey, thanks again, Dan, for chiming in for Canada. I appreciate you coming in here. Enjoy your computer project, sir. It's all good. All right, so here we're going to take this part of the equation and continue with the square root property, guys. That's what we're going to do. Looks like I need to add a page in here, so let's do that. Let's go ahead and add a page. All right. All right, so we'll be using the square root property to solve this problem, guys. All right, so we're going to start out by taking the square root of both sides. We have the square root of x plus 1 squared equals to the square root of negative 3 halves. We'll go ahead and rewrite the right side by splitting up the radical into the square root of -3 divided by the square root of 2, and then we'll rationalize this by multiplying the numerator and the denominator by the square root of 2. So on the left side, we end up with the absolute value of x plus 1. We have to guarantee that the left side's result will be positive. Anytime you use the square root sign, the result must be positive. So that's why we're guaranteeing that our result is positive by using absolute values around the quantity x plus 1, because currently we don't know what x is. So just in case x happens to be a negative value that's greater than 1, we want to guarantee that that result will still be positive no matter what by placing our absolute value signs there. So by taking the square root of x plus 1 squared, you will write the absolute value of x plus 1. Okay? Then on the right side here, we'll end up with the square root of -6 divided by 2. Absolutely. And using complex numbers, we'll go ahead and show that this is going to be the square root of 6i squared divided by 2. And even better, we can show that this is going to be I times the square root of 6 divided by 2. Okay? So on the left side, we have the absolute value of x plus 1. And this equals to the square root of 6 divided by 2i as a term. So using our solving this absolute value equation, we want the distance from 0 to be the square root of 6 divided by 2i. So we can set up two different equations to make that happen. The first equation will be x plus 1 equals to the square root of 6 divided by 2i, or you'll have x plus 1 equals to the opposite of the square root of 6 divided by 2i. All right. So that value, that distance from 0, could occur to the left of 0 or to the right of 0, which is why you need two different equations to solve this. All right. And let's go ahead and add another page. All right. So this one was page heavy as far as the steps are concerned. We got to make sure we have enough pages to solve this problem, guys. All right, that's what we got to do. Angry Hermit says, I have to go edit my essay. Thanks, and see you later. No problem, Angry Hermit. Good to see you today. Thank you for chiming in. Always a pleasure seeing you. And have fun with your essay. Have fun with your essay, Angry Hermit. Good deal. Angry Hermit always holding it down for us, guys. She is what we call a loyal participant. Okay, so here we have it. Our two equations that need to be solved. We'll be subtracting one of both sides in the first equation to end up with x equals -1 plus the square root of 6 divided by 2i, or subtracting 1 in the second equation, you'll have x equals, that equal sign was ugly. We'll have -1 minus the square root of 6 divided by 2i. Okay, there you go. Those are your solutions there. Those are your solutions right there. Raul, do you see how I end up with the solution that I have? Check that out and see if you got it. And because you have to write your answer in A plus BI format, that's why you cannot combine those, all right? It needs to be separated between the real and the imaginary part. So as a solution set, let's go ahead and see. All right, not as good as a brace as earlier. Okay, that's a decent brace for me. So we'll leave that as B. Leave that as is. We'll have -1 minus the square root of 6 divided by 2i. That's the first solution. And you'll also have -1 plus the square root of 6 divided by 2i as your second solution. And we will red box it. All right, there we go, guys. So make sure that I did all of that correct, guys. Make sure, Raul, that I didn't make any mistakes. And that is what we have for problem number, whatever that number was, 36, I would imagine. Yeah, problem number 36. Done and done. Okay. In problem number 37, we have an absolute value equation. They ask us to solve the equation. All right. And there are a couple of strategies to solve this, guys. There are a couple of strategies to solve an equation like this. And I think, guys, all right, I think I'm going to be taking the long route on this because it is a route that will always work. Okay. So I'm trying to see what the proper way to show you guys this, because I know the way I normally do it. You know what? No, I'm going to do it my way. That's what I'm going to do. I'm going to do it my way, guys. That's what I'll do. My way to solve this problem is to first of all analyze the equation. Recall that the absolute value is a distance problem. It's the distance to zero. And that distance to zero must be either a positive number or zero. Okay, it can never equal to a negative number. So the deal is, in this particular problem, is that we have an absolute value on both sides of the equal sign. Well, this is definitely a possible equation because the left side and the right side both must be either a positive number or a zero. So it's possible. Okay, so that means that we are going to say that the distance, which is obviously equal to one another, can be gotten. All right, this distance needs to be the same value either from the left or the right of zero is what I meant. Okay, so we're going to go ahead and rewrite it as x plus 5, okay, can equal to 2x minus 1 if it's a positive value. All right, or it needs to equal to the opposite of that value. All right, because once again, it's the distance to zero. Thank you for your support, Jamila. All right, so bottom line is 2x minus 1 is a number. It's a distance from zero. And either the positive value of that or the negative value of that is what we'll have as a distance from zero. And that's why we'll solve these two equations to get our answer. So to solve the first equation, we'll subtract x to both sides. I'll have 5 equals to x minus 1. Adding 1 to both sides, we'll end up with 6 as a possible result that we'll need to test. Okay. Then we'll distribute the negative on the right side. We'll have x plus 5 equals negative 2x plus 2. Plus 1. Sorry about that, guys. And then in solving this equation, we'll be adding 2x to both sides of the equal sign, like so. I'll be bringing down 3x plus 5, which equals to 1. I'm going to be, that equal sign is ugly. The equal sign was ugly. I had to fix it. I had to fix the equal sign. Thank you. Appreciate that. Then we'll be subtracting 5 to both sides. Hi, guys. And you'll have 3x equals to negative 4, and then divide both sides by 3 to get x equals negative, get your lie together, x equals to negative 4/3, possibly. All right. So the bottom line is that in plugging these values into your original equation, they have to make a true statement. Christopher Patrick says, love your videos. Christopher, my videos love you. Okay? And don't you ever forget that for the rest of your life. Thank you. So when you're in your dark times, sir, Christopher, and you're feeling sad and down about everything that's going on around you, you just come to Forbidden Tutoring and look at all of the videos, because they all love you. Okay? You got that, Christopher? Thanks. All right. Raul says that 6 and negative 4/3 are both satisfied. Let's check that out. Jamila says, ah. All right. Let's go ahead and check this out. If we plug in 6 plus 5 is 11. The absolute value of 11 is 11. And if we plug in 2 times 6 to get 12, 12 minus 1 is 11 as well. The absolute value of 11 is 11. So therefore, 11 equals to 11. So that works. That's fine. That's okay. We like that answer. Let's see what happens when we plug in negative 4/3. We would have the absolute value of negative 4/3 plus 15/3. And that would give us 11/3, and the absolute value of 11/3 is 11/3. Okay. However, on the right side, we would say that we had 2 times. We would say the absolute value of 2 times. Let's see here. Parentheses looks like an absolute value symbol. It would be 2 times negative 4/3 minus 1. This equals to negative 8/3. Okay. That would be negative 8/3 minus 3/3, which is negative 11/3, and then the absolute value of that negative 11/3 is 11/3. So they both check out as Raul stated. Raul, you're absolutely correct. So therefore, this problem number 37, our solution set is negative 4/3 and 6. Both results work in the original problem, and done. All right. So when doing problems like this, it's always a good idea to check your results in the original problem to see if you don't have any extraneous solutions. Okay. So that's what we had, and those are the answers for problem number 37, done and done. And notice that the first thing we did was we analyzed the equation to see if it was even possible, guys. All right. Now, last time we found the vertex using the equations for finding the vertex. But this time we are going to solve the equation. We're going to write this in vertex form, guys, using completing the square, which is going to be fun. Tony says, try to factor by grouping. Oh, awesome. Brace, Noah. Yeah. And Tony, we have a video on factoring by grouping in our factoring playlist on the YouTube channel for Ben Tutoring. There's a playlist called factoring. And within that is a video called factoring by grouping. That's right. Please share that with your son, Tony. All right. So here we have problem number 38. It says the vertex of the parabola with the equation, y equals 4x squared plus 8x plus 7. We're going to use completing the square to put this equation into vertex form for a parabola. Just to let you guys know, that form is y equals a times the quantity of x minus h squared plus k. This is the vertex form of a vertical parabola. All right. And we're going to use completing the square in order to put this equation in this form. And we didn't do a problem like this yet. So this is a good problem to see. We have the first thing that we'll do, and that is to factor out 4 out of the first two terms. We won't be able to simplify this equation, guys, because we cannot touch that y on the left side. That y remains the same throughout this entire process. So we're going to factor out 4 out of the first two terms in our equation. We got Christopher over there laughing out loud when I was messing with him earlier. So we have 4, and we'll have x squared plus 2x blank. This is going to be plus 7 blank. There we have it. Amen, amen. And you'll be taking half of the middle term's coefficient. So take half of 2, which is 1, and then square that value to get 1 here. But because we cannot add any values on the left side, in other words, we can't mess with that y on the left side, it needs to stay a y, we will be offsetting the value that we just created here in order to complete the square. So we placed a 1 inside the parentheses, right, guys? But we won't be offsetting that with -1. No, we won't be doing that at all, because that's not its true value. The true value of the number that we put inside of that blank there is 1 times 4. So we need to offset 4, guys, because don't forget we had 4 on the outside of that parentheses multiplying times everything within. So if we put a 1 in the blank, that 1 is still being multiplied by 4 on the exterior of the parentheses there to give you a true value of 4 for that 1, because that 1 times 4 gives you 4, right? So to offset that, we'll be putting a -4 in this blank on the outside. Oh, yeah. And with that, we can now factor this. Get my words together. We'll have y equals to 4 times the quantity of x plus 1 squared, factoring that perfect square trinomial, plus 3 after combining the 7 minus 4. And if you've been paying attention to my original form here, the vertex, guys, will always be in the form of hk when dealing with a vertical parabola. So the vertex of this parabola then is going to be the opposite of the sign, the opposite of the value inside the parentheses, which will be -1, and our k value, which is 3. So we end up with a result of -1, 3 for the vertex of this parabola. And we did that by placing the equation in vertex form by completing the square. All right. So we approached this problem differently from the other problem that I had in this college algebra review, part 1. We use completing the square, guys, to get our equation into vertex form. Amen, amen. And then we boxed it. That's right. Raul says, do I have any videos on that concept? Absolutely, Raul. I sure do. It's called Graphing Vertical Parabolas, and it goes over finding the vertex using completing the square. It sure does. It's called graphing vertical parabolas. Yep. Graphing quadratic functions, vertical parabolas. And you'll see in that video the technique that I just used. All right. Good stuff. Glad I could share with you, sir. And matter of fact, Raul, let me go ahead and find that for you. I'll go ahead and hook you up. Okay. With the link. Give me a sec. All right. No problem, Raul. I'm here to help, man. Here to help. Let's see about this. Helping out Raul. Getting this link. Getting the link for Raul, guys. Give me just a second. I almost have it for him. There we are. And getting here. Almost there, guys. Almost there, guys. We're going to share this. Almost there, guys. And we have the link now. Okay. Better. All right. I got it, Raul. Here we go. I'm going to paste it in the chat for you. Bam. Okay. That's it. That is the link, sir, to that video. Let's go ahead and look at problem number 39, guys. Problem number 39. So that is the link to that video going over graphing vertical parabolas. In problem number 39, guys, it asks us to graph the exponential function y equals 2 to the x. And what we'll use in order to graph this, guys, is a XY chart. Yep. I'm going to use an XY chart to graph this equation, guys. That's what I'm going to do. And you know what? Let's go ahead and give ourselves something to work with here. Yep. There we go. Got us a graph now. Rose says, that's so nice of you, sir. I will surely visit it and learn the concept today. All right. Good deal. Thank you, sir. I hope that helps out, Raul. The values that I'm going to be plugging into this equation, guys, are going to be the following. I'm going to start at 0 in the middle. And I'm going to go to -1, -2, 1, and 2. I'm going to use these values to graph this point. Graph this function here. I have freedom on my domain. If you look at the equation, you don't have any domain restrictions. There's nothing preventing you from plugging in any number you want into this equation. So I'm going to use some small numbers. Yeah, like 0, -1, 1, -2, and 2. Because I'm lazy and I'm not trying to get stressed out here. You know what I mean? So let's start by plugging in 0. Plugging in 0 into our equation, we would have 2 to the 0 power. Well, that equals to 1. That ought to be easy to plot. Then let's go ahead and plug in 1. 2 to the first power. That's 2. Another easy point to plot. Then plugging in 2. 2 squared is 4. That ought to be easy to plot. Thanks. Then 2 to the negative first power is the same thing as 1/2. Yep. 2 to the -2 power is the same thing as 1/4. There you go. Now I got 5 points to plot. I'm happy. You know what I'm saying? They tried to stress me out with this problem, guys. They weren't even ready for us. They were not even ready. Not even close to being ready. Nope. Also, just keep in mind that you will have a horizontal asymptote of 0 on this. Okay, we won't be touching the x-axis with this problem here, I don't believe. Let's check it out and see. At -2, I'm at 1/4. That's going to be right above the 0. Let's go ahead and fix it. Let's go ahead and fix it. Yeah, that's a good point. That's a good point. We'll keep that point right there. Then at -1, I'm at 1/2. All right. Oh, that's an ugly point. That's a little better. That's close to 1/2, right? Then I have 0, 1. We got a point right there. That's a perfect point. That's a perfect point on the y-intercept, guys. It doesn't get much better than that. Thank you. Thank you in advance for that point right there. That is perfect. Then we have 1, 2. That'll be right there. That's not a bad point. It's not bad. It's a little off, but we'll keep it. And then we have 2, 4, which is here. There we go. So we see that exponential form, guys. So let's go ahead and draw our graph. Remember, you're not going to be touching the x-axis. It's going to be getting close to the x-axis, but not on the x-axis. All right, so that's just going to be a little bit above like that. So this is our graph, just like that. Not bad, Mr. Witt. There it is. All right, so so Raul says as x tends to positive numbers, let's see, the function will tend to infinity. That is correct. And as x tends to negative numbers, the function will tend to 0. That is correct. Yes, Raul, you're correct. But it will not become 0. It gets closer and closer to 0. All right, but it never touches 0. And it does go to positive infinity as x approaches infinity. That is correct. Raul, you're on point. You're on point. Yeah. You know what? Let's go ahead and do something better, guys. I think Raul is on to something. Let's go ahead and discuss the domain and the range of this. The domain and the range of this function. You're on to something there, Raul. Okay. Thanks, Jamila, for your support. Jamila says not bad at all. Let's go ahead and put that chat back up there. So here, guys, our domain, as I told you at the beginning, there's no domain restriction. So your domain for this is negative infinity to positive infinity. All right, you can plug in any number. You're not trying to take the square root of a negative number. You don't have 0. You don't have a possibility of getting 0 in the denominator of a fraction. Okay, you're not taking any logarithms on this problem. Okay, or no natural logs. So you don't have any domain restrictions as far as that is concerned. You don't have any trig functions to be worried about. Okay, so that's right, Raul. Your domain is all real numbers, or in interval notation, as I put it, Raul, it's negative infinity to positive infinity. Okay. Then, for your range here is going to be as you see it in the graph. Remember, it's going to be from 0 to positive infinity. Okay, so to remove the chat again so you can look at that graph, we're not touching 0, guys. We're getting closer and closer to 0. So therefore, in interval notation, it's going to be from 0, not including 0, so you don't use a bracket there. Use a parenthesis, not a bracket. A bracket would be including 0, and you can't include 0 in this problem because the function never touches 0. It just gets close and close to 0, but never touching it. And then we go to positive infinity. All right, and that is the range. So if they were to ask you the domain of the function, you would give them the domain is negative infinity to positive infinity. The range is 0 to infinity. If they ask you for the horizontal asymptote, you would give them y equals 0 as the horizontal asymptote. Okay, so there you go. Yeah, if they wanted to know the y-intercept, let's look at that. Boom, the y-intercept is 0, 1. Okay, so just in case they ask you for several things in a graph like this or in a function like this, those would be the answers to that, guys. All right, so I want to give you something extra for problem number 39. So the question just asks us to graph it, and we did that a long time ago. But just now that I can think about it, sometimes on your final exams they could ask you things like what's the horizontal asymptote of the function, of the exponential function. They can ask you stuff like what's the domain and the range. They could ask you for the y-intercept. You see what I'm saying? So therefore, I wanted to give you more for your money. You know what I'm saying? Give you a little icing on the cake, you know what I'm saying? Little sprinkles on that there. I'm gonna move on to number 40. I'm moving on, guys. I'm sorry, I just got beside myself. Number 40. Here we go. Number 40. They're talking about transformations of graphs. So it says begin by graphing the standard quadratic function f of x equals to x squared. Then use transformations to graph h of x equals x plus 4 squared plus 6. Well, let's do just that, guys. Let's do just that. And we're going to do that using an XY chart. Okay? I want to do that using an XY chart. That's what I'm going to do here. Yep. That's going to be what I'm going to do. All right. So using an XY chart, we are going to find out the transformations. Polar King says, it's been fun, but I have to pack tomorrow's work trip. I understand, Polar King. Go make that money, sir. Go make that money. Polar King. All right, good deal. Jamila is laughing out loud. She is laughing out loud. All right. So this is going to be our original function, f of x over here. Whereas this second XY chart is going to represent our transformed function. All right. So for our parent function, I'll be using the values 0, 1, 2, -1, and -2. Plugging in, all right. Polar King says, got to make more money so I can donate more. I am not going to be in the way of you doing that, Polar King. You go ahead and make as much money as you possibly can. You feed yourself and your family and keep a little extra for your friends in case they have a little hard times. You can help them out and then give all of the rest to Fort Bend Tutoring. Just kidding, Polar King. Thank you for stopping by and enjoy your work trip there. Good stuff. Rose says y equals x squared will give a graph passing through the origin. That is correct. Absolutely it will. And we're going to prove that, Raul, by plugging in our values that I just generated here. Okay, and guys, just keep in mind that I made up these x values here because our domain for the function of f of x is all real numbers, so it doesn't matter. It didn't matter what values of x you chose. I just chose small numbers. All right. So that's good. Polar King said, y'all in my wheel. Thank you. That, sir, is an extreme honor. Jamila says, psych. Polar King is not playing, Jamila. He's serious. I hope he is. That's too funny. All right, guys. Take care. Polar King, you keep this up. You're not going to leave. All right. So here, guys, on problem number 40, I'm just going to fill out these XY charts that we can use to graph. Okay. That we can use to graph here. And that being the case, we'll have the following. We will have the following here. We have 0 going into x squared. So 0 squared is 0. So that gives us our y value for that x value of 0. Plugging in -1 squared is 1. Plugging in -2 squared is 4. Same thing goes for 1 and 2. Okay, so we have our points here. So what we have now is an opportunity to show our transformations. What you have inside of the parentheses is called a horizontal shift. Your horizontal shifts move in the opposite direction that you would think they do. So with that positive 4, that's actually going to subtract 4 from your x values. So it's going to be your x value minus 4. Whereas on the outside, that positive 6 is a vertical shift up. So that's going to take your y value and add 6 to it. So what I'm doing here is I'm writing a rule for my points in H. So all of the x values in my f of x function, I'll need to subtract 4 from those values, and all of the y values, I need to add 6 to those values. All right. And of course, on your graph, you can graph this out to show your parabola initially. Okay. And we'll do that on the next page, just to let you guys know. So start out by subtracting 4 to each of your x values. So -2 minus 4 gives you -6. -1 minus 4 gives you -5. 0 minus 4 is -4. Then you'll end up with -3 and -2, right? Okay. For your y values, you're adding 6 to each of these values. So 4 plus 6 is 10. 1 plus 4 is 5. Excuse me, 1 plus 6. I'll need to be adding 6, right? 1 plus 6 is 7. Thank you. 0 plus 6 is 6. 1 plus 6 is 7. And 4 plus 6 is 10 again. All right. So these two XY charts are what we'll use to graph the function f and h on our Cartesian plane. Let's go ahead and hook up that graph paper. Here we are right here. And let's go ahead and grab these XY charts as well to help us out. All right, so we have our graph of f and our graph of h, and they asked us to graph those both using the transformations, and that's exactly what we did. Okay, so there we go. All right, so let's start out by graphing our, let me get some orange juice. I'm getting a little, throat getting a little dry, guys. Nice little orange juice break right there. Nice little orange juice break, guys. There we go. All right, so what we have now is our opportunity to graph the parent function. So we have a point at 0, 0. All right, let me get it together. Let me start over because it's just ugly. There we go. Better. Then we'll have a point at -1, 1. We have a point at -2, 4. All right, and we have a point at 1, 1, as well as a point at 2, 4. And connecting those dots together, we'll have our, we got to make it pretty for Jamila. There we go. We have our vertical parabola. There we go. Done. Okay, that's the parent function. However, we will also be graphing our transformed function h. And we'll do that by graphing the points that we have here. So the first point we'll graph is the vertex at -4, 6. So we have it at -4, 6 is a point right here. Good. That's a good point right there, guys. Then we'll have -3, 7. We also have -5, 7. There we go. We have -6, 10. That gives us a point here. And we have a point at -2, 10. Okay. And then we'll go ahead and show that graph. All right. And then we can even label this. So this will be our graph of f of x here, guys. Just to show off to our teacher. And then this is our graph of h of x. There we go. And we use transformations in order to get there. Tracy Thompson hit us up, guys, with a $5 donation. That's what's going on. Tracy says, you're going to help me pass my final this week. Absolutely, Tracy. And Tracy, let's go ahead and immortalize you, girl. That's right. Tracy Thompson is in the house, guys, with a donation to Fort Bend Tutoring of $5. Thank you so much, Tracy. This will help us tremendously in bringing you guys more free content. All right. The more you guys help us, the more we're able to help the world. So by helping us, you're not helping just us. You're helping many, many people down the line. I really appreciate that, Tracy. Once again, Tracy said you're going to help me pass my final this week. Absolutely, Tracy. Don't forget to check out part 1 of the College Algebra final exam review if you didn't check it out already. Thank you so much. So this was transformations of functions, guys. We had a horizontal transformation as well as a vertical transformation, and we made a rule for that and applied it. Absolutely. Good stuff. Good stuff. And this was our result. And this was our result right here. Good stuff. Because of Tracy's donation, guys, I got to keep going. I got to keep going with this next problem here. I was going to stop at number 40. But we got to keep going, guys. Jamila says, this is what I had to work on. I learned to do this a little faster on my exam because I was trying to make all of those lines. Ah, yeah. Yeah, I hear you. I hear you. You said all those lines. I hear you. So hopefully this process helped out then, Jamila. Is that what you're saying? Good stuff. All right, let's look at problem number 41, guys, because in problem number 41, we have a rational inequality. Okay, so this is going to be a first for this review. I have shown you guys a rational inequality, and they also want us to graph it on a solution set on a real number line and express the answer in interval notation. So this is a good problem. The first thing you want to do, guys, is identify your critical points in here. You can find your critical points by setting the numerator equal to 0. All right. As well as setting the denominator equal to 0. As a matter of fact, you can say that it's not equal to 0, all right, as far as the critical value is concerned. Because any value that makes the denominator 0 would be undefined. So keep that in mind. So we'll have x minus 3 equals 0. That's okay. And then we'll say that x plus 2 cannot equal 0 because that'll make the entire rational expression undefined. So what you'll do next is solve for x in each equation. So you'll add 3 to both sides to find out one of your critical values is 3. And then in the second equation, or inequality for that matter, because we have it not equal to 0, you'll find that x cannot equal to -2. So -2 and 3 will be the critical values for this problem. Okay, now that we have this, let's make a sign chart. So the sign chart will consist of the factors x plus 3 as well as the factor x minus 2, I believe was in the denominator, guys. Let me go ahead and fix this, make sure. No, we had x minus 3 and x plus 2. Let me fix it. Let me fix it just to make sure. One more time. X minus 3 and x plus 2. All right, good deal. So we had a factor of x minus 3 and we had a factor of x plus 2. There we go. And then on our number line, we're showing the critical values, which are -2 and +3. All right. Jamila said, yes, this helped me, and practicing also helped me because those lines are time-consuming. The functions, you're graphing them. Absolutely. Absolutely. By using the rule as we did in the previous problem, Jamila, that could speed you up quite a bit. All right. Absolutely. So, thank you, Raul. Yeah, we use -2 and 3 as our critical values. I appreciate that. So what you want to do at this point, guys, is you want to come up with a test point. Your test point needs to be a value that is smaller than your smallest critical value. So I'm going to use -3 as my critical point or my test point. You only want the signs of the results here. So plug in -3 into the first factor. You'll know that -3 minus 3 is -6, right? So we'll have a negative result here, and it will remain negative until you get to 3, where it will become 0, and then after that, those values to the right of 3 will be positive. Plugging in -3 into the second factor, you'll have a negative result. At -2, you'll have 0. Then these values will become positive after that value of -2. So remember that originally this inequality had to be less than 0. And these factors are dividing, right? So that means that we want the results of this to be a negative value, not equal to 0, but negative. And keep in mind that at -2, this value would actually be undefined. So it's not going to be 0. Your teacher told you to get a ruler? That's funny. That's funny. See, they trying to stress you, Jamila. They're trying to stress you with those lines. You poor thing. Your lines were all crooked, huh? All right, so remember we're dividing these factors together. So a negative divided by a negative is a positive, guys. Here we'll end up with the problem being undefined. A negative divided by a positive is a negative. 0 divided by a positive is 0. And a positive divided by a positive is a positive. But what we want are negative results, remember? We had that rational expression being less than 0. So we want the result to be negative, and that only occurs between -2 and 3. So on our number line here, on our graph, on our real number graph, we'll show that it cannot equal to -2 nor 3, because it can't equal to 0. It has to be less than 0. And everything in between these points, these values, is where you'll find your solutions. So your answer here is -2, 3, just as Raul has it, and this is your answer, and we are red boxing it. Ladies and gentlemen, this completes the college algebra final exam review. You have been with me, Mr. Witt, and Fort Bend Tutoring, and I appreciate you guys. Thank you guys for chiming in with me today. And as always, please rate, comment, and subscribe. And guys, check us out as we will start looking at the 8th grade and high school classes starting this upcoming Thursday with their final exams, getting them ready. And in the future, guys, I know some of you was waiting on, for instance, pre-calculus and trigonometry and calculus and all that kind of stuff. We will be doing those final exam reviews at a later date and time, not this school year. All right, we'll do that later on as I get more comfortable with my live streams, because I had to make sure that I could handle all this all at once while giving you correct information. All right. And as those classes are more challenging, I wanted to pace myself. Raul said, I just discovered this great man in the live stream today only. Okay, Raul, well, go ahead and subscribe to the YouTube channel and click that bell notification so you'll know that when we're going to be live streaming in the future. And also check out our content that we already have on Fort Bend Tutoring. Michelle says, thanks so much. I just discovered us yesterday. Thanks again, Michelle, for chiming in. That is good. It is a blessing for all of us to join in together in our academic pursuits. Thank you so much, Tracy Thomas, for your donation today. Thank you, Polly King, for your donation. I appreciate it, guys. You guys, it has been a blast hanging out with you today. Thank you so much for joining me. And as always, please rate, comment, and subscribe. If you're able, please donate using the donation link in the description box if you didn't catch us live. And please check out our affiliate store on Amazon. We have a link in the description box as well. And also, go ahead and check out our t-shirt shop, as you can get some cool t-shirts to support Fort Bend Tutoring. Rose says, punch that bell icon. You got it, guys. Punch that bell icon next to the subscribe button so you'll get notified when I'm live again. And Jamila says, yay, the live stream. That's what's up already. So I want to give some shout outs here to Jamila, Raul, Michelle, also to Polly King, also to Tony and Noah. All right, his son. We also had Christopher Patrick in the house, hanging out with us for a little bit. Angry Hermit stopped by for a little bit. Dan from Canada was also in the house today. We also had Lorna in the house. Libby was in the house. El Pollo Loco was in the house today. Danielle was in the house. Thank you, Danielle, for coming by and chilling with us today. And we also had Bronze Beauty stop by for a little bit. We had Doreen come in for a little bit. Stephen Chong came in. Thank you guys for stopping by. Mario Dela Cruz came by for a second. Appreciate you guys coming in. And guys, thank you so much for making this live stream that much more powerful. You guys take care. Peace.
Thanks for watching. We appreciate you hanging out with Fort Bend Tutoring. Like the video, comment, and subscribe. Hit up our website, tutoringmath.net, and set up a private tutorial with me and FBT. Oh yeah, baby. Thanks for